Thanks, Mo. Thank you a lot for your keynote speech and the introduction. Hello, everybody. My name is Daniel NEUBIG. I'm technical lead for Augmented Reality at Ergon Informatik. We are a software company based in Zurich. We are creating individual software solutions for Swiss B2B market, and we're also offering a web security suite called Ergon. I wish you all a great day, and I have the honor to start track 1 and talk about collaboration in AR. We are all collaborating every day. In teams, we do communicate, we interact, we share our thoughts, we describe our ideas, we design and discuss, and based on these discussions, we think we understand how others see the world. But developing the same understanding is quite hard. There are always misunderstandings. It takes a lot of time and effort to describe a design to somebody. And even if I would invest a lot, and even if I would do my best to describe to you, for example, a black couch with a print of white leaves on it, I cannot tell if you would imagine something like this. And additionally, there are some people having a hard time to imagine something three-dimensional. I cannot tell if the room would look a lot better if the wall on the right would be green instead of blue. So we use models, we use renderings, we use drawings to visualize our ideas. Augmented reality is changing how we can do that. AR allows that we view and we interact with some virtual content in real time in the real world. These virtual elements can add something to the scene, or they can even change it completely. This is IKEA's famous example how they started AR many years ago. But AR can not only be used as your personal shopping view to plan your next living room. It can also be an invitation to others to see the same view together. We can give other people access to what we see and what we experience. We can share what we imagine, what we're creating. And for the first time ever, that's an active collaboration in real time. We're not just sharing a video stream or FaceTime with each other. AR offers an interactive way that we work together. Collaboration means we're working together. I will show different ways and examples how that can look in AR. The technology is ready to provide a multi-user real-time view, and we share it. All those people wearing those connected head-mounted devices, they all see the same hologram, so they can base the discussion on the same understanding. We can implement ways to show additional details about this, for example, this building. Features like simulating the sunlight, the ventilation, or different variants of the building. And the benefit is everybody can easily understand the same idea and then express their opinion. Another use case is an app called Remote Expert. That's a video conferencing service. As a user with the head-mounted device, you're adding a video conference screen in your site. An expert can join you remotely and see your view through the camera of your headset. So you can both interact in the 3D scene in front of you. For example, you can discuss something, or you can annotate, in this case, a wire which explains the next step you have to take. You can easily consult a colleague to discuss a complicated step or have a peer review on site, while you normally would work alone and might be unsure about the correct handling. The expert in the video can even have multiple calls during the day and help people without having to travel to the site. During COVID-19, hospitals are using exactly that idea to expose less people to the virus. Only one doctor needs to enter the ward with the patients. And like the remote expert, this doctor can share his or her view, and the HoloLens will send a video feed to the safe room away from the ward, away from the virus. Important thing is, the doctor is still able to interact with the others and has hands free to work just like normal. The remote team can add information like medical notes about the patient or x-rays as holograms for the doctor, embedded in his view. By using voice commands and gestures, the doctor can access this information without needing to touch as many objects inside the ward as normally. Therefore, you can save PPE, so personal protective equipment, and more people can stay safe away from the virus. Thing is, those head-mounted displays and devices are still quite expensive and are still quite hard to get. I tried to collect a few numbers to compare. All those numbers I estimated, those are not official numbers, but I tried to make a point here. HoloLens, let's say HoloLens 1, let's say they sold about 100,000 devices, which is a lot. HoloLens 2, they said, okay, they already sold, in the first half a year, they already sold more devices than the HoloLens 1. It's still hard to order some of them. Magic Leap 1, they aimed for also 100,000 devices, but rumors say they sold just very few of them. So overall, there are just a few 100,000 devices of those. And most people did not wear them at all, or maybe wore them once. And you still have to convince people where the benefit is that they pop up such a device. Phones and tablets on the other side, they are common and widely available. I'm sure that in the upcoming future, we will see more cases like the ones we just discussed. But today, I want to show you that we can bring the same benefits to everyday hardware. I will show you 3 examples of mobile AR apps running on devices, on mobile devices and on tablets. My first example is the SmartCity app we built for the city of Zurich. Imagine there's a new building in planning. In this case, a new school is required in a neighborhood in Zurich. The architect did design a few different versions and based on the official requirements. And now some people need to decide which model will be chosen. And then you need to adapt the model and need to work on them on different improvements on the model. So far, the architect delivered a technical description, an explanation, and physical models or some rendered visualizations. This time we also collected digital 3D models. The AR app on the iPad can load and visualize these schools at the outdoor location. So from now on, you can go there and get a good own feeling for the different designs and sizes. How did we achieve that, and what's so important about that? Well, the school needs to be located at the correct place. The size and the orientation need to be correct as planned by the architects, that you can compare it. We're using a digital 3D model of the city to handle all the surroundings, the terrain, and the other buildings which are there. And we use the 3D school models. All objects are GPS located, so we have a very precise scene we can merge from school and surroundings and then render. A visual positioning system identifies where the user is located and where the virtual scene can then be anchored into the real world. For the user, all that it's really easy. You go there and you start a video. We identified a few things users want to find out about the building when they are at the location. For example, they want to compare the different models, so you can swap between different versions. Still, all versions are having a similar texture that you can compare them easily. You can interact with the model by selecting certain parts and modifying it, for example, hiding certain parts. You can simulate the sun to see where the shadows will fall at a certain day and time during the year. And right now there's a parking lot at the location, so we added a virtual floor which is blocking the view on that you can immerse yourself in the future scene. And the virtual people, those low polygon people we added, they give an additional relation to the distance and the size because the virtual object is quite large. Here's a screenshot of the iPad. The building on the right is a real building. The floor, the people, and the building on the left, those are virtual. We reused the existing 3D models and presented it in a new way. It's easy to use. And good thing is there is no required hardware to set up. The second screenshot here shows a different school model, obviously, and a different view angle with some more details, which also are running quite fluently on the iPad. So whatever the architect delivered as a model, we can just reuse on the iPad. So now you can walk through the building. You can go inside and understand the ideas of the architect and then discuss it. And best thing is, you don't have to imagine that because it is right there. Based on this experience, people have a better vision and can see more details earlier in the programs. The team has a similar understanding and then can discuss based on that similar understanding. During planning phase in the beginning, you can easily adapt the model before it is built and before you might realize that it's completely different than what you expected. My second example is something we built for the Zoological Museum in Zurich. They have a team with members working in design, in education, and in construction. They're working on different exhibitions and events throughout the year, and the topics, the concept, and the story, they are all created internally. So everybody is bringing their own expertise, and together they want to create something interesting, informative, pleasing, and a safe exhibition for the visitors. During the work on the exhibitions, new ideas are evolving and plans need to change. They are also designing and building custom furniture in-house. So the construction planning is already done in a 3D software they have. So far, they still had to create physical models or renderings to explain a new version and then discuss it. Adapting the physical models always required additional work. The new AI app can dynamically load their custom 3D models, and the team can use then physical anchors to place the virtual content directly into the museum. You can move the physical anchors to try out different layouts and also measure the space. Size and materials and colors, they are already defined in the 3D model you can load into them. Imagining an exhibition in an empty room is quite hard, with all the lighting and all the distances and sizing. But now you can take a 3D prototype and get early feedback on design, on usage, on size, on colors, materials, and the 3D designer can try out different versions and show it directly. The full team can use the AI app to decide if the model is suitable and how to adapt it. For example, how much text needs to be placed, and can you read it properly? Is it large enough? A second mode of the app allows to place a small virtual model of the exhibition on a meeting table in scale 1 to 20. That's quite useful to share the same model during a team meeting and discuss it there. The app is quite easy and fast to use, and it provides a common view for the whole team. All team can then evolve and discuss with less misunderstandings, and everybody evolves their own wishes and needs and expectations already during the progress. The process of adapting is now a lot easier as they have very fast feedback loops. My third example is an app called Fieldwalk. Fieldwalk offers a platform to handle issue management during construction work. And working at a large construction site means there are many people and companies involved. So if errors occur, and they do occur, somebody needs to identify and assign and track them, and also verify that the error will be fixed and if it's fixed properly. Construction managers and builders, they are dealing with thousands of these issues. And Fieldwalk provides an easy and fast way to manage all that. Once every week, managers meet for a walk, and there they decide and discuss at the construction site what needs to be done and verify the progress of what was done. And at the end of such a walk, there's a protocol for all the team members to store what was discussed. This new platform helps tracking all these issues. It offers fast creations of new issues and allows an efficient way to track them. The goal is that everybody can work on his or her tasks, and the app provides an easy access to the relevant information. And to be honest, these walks are very efficient. Most of the time, everybody's quite good informed and aware of their own tasks and what was done, and so that they share their information, they share their status. It's getting a lot harder when some information is missing, because then the discussion is starting, and that costs some time. It is hard to access the planning data at the site and compare the drawings with the model and with the reality. What can we do? Well, those construction sites are often already planned by using a BIM model, a building information model. That's a 3D model which contains all the information about each wall, floor, screw, door handle. And Fieldwalk now links those 2D plans with a 3D model and the issues, and to be able to access all the relevant information. With AR, we are even providing this information during the walk at the site. We're using indoor navigation to track where the user is at the site, and then you can switch between a 2D view, where you see a map and you see where all the rooms and where you are on the map, and all the different issues you might need to check. And we have a 3D view. That's the model we use then for AR. Here you have all the colorful different disciplines. So you have water and electricity and dirt water and air ventilation and all the different disciplines color coded in the model. And you can use that at the construction site. How will that look like? Well, you can see the floor, which is currently built with all the floor workers, and a transparent AR view. That's a screenshot from the iPad. On the top right, you see the map where you're located right now, and you see the whole floor, which is currently built as an AR overlay. So if you are in doubt, you can always access the information about either the whole discipline or a specific part of the model, a specific column in this case, to find out when is it built, what material, the dimensions, the IDs, and all the information from the model. Here you see another screenshot of a screenshot from the iPad, where you see the overlay, the AR overlay of a ceiling. If there is an error, you can point at a certain part of the object of the model and link a description to that specific part. So it's a lot easier to identify a specific object and then discuss further from there. So Fieldwalk is in the end a quality assurance tool using AR to save time in handling the incidents, and save time in gathering the necessary information if it is an incident at all. It is quite easy to onboard everybody. So when it's running on an iPad or an iPhone, you don't have to hand out HoloLenses to everybody. You can access the model and the incidents directly on your phone. And apart from AR, we already measured that collaborating on the construction site already improves the handling of the incidents, and there are less errors because people are discussing it earlier and have a proper link to the construction site where the errors occur. So the building information model, indoor navigation, and AR, they provide just an additional interface to access all the information we already have. The building is already planned with all the details. I want to summarize that and share a few tips how to get AR integrated in your business. Make it usable. Find things that are not possible on a PC. AR might help you there, but AR alone cannot solve everything. Make it easy. Nobody is used to work in space. We all need to learn, and we are starting this. So nobody is used to it yet. Make it relatable. You need to understand what the users are currently missing and solve their problems. Make it pretty. it should be easy to use and still look nice. Otherwise, it's hard that users will accept it, and then if they're not accepting it, they're not using it. Make it minimal effort in case of 3D models. So reuse existing 3D models, or start with a very limited set, but creating new 3D models in the thousands is a lot of effort. Make it interactive, share the view. That is one of the big benefits. And last part, make it safe. It's one of the most important things. And I didn't cover a lot of that, but I need to mention, inform and protect your users, because privacy and security about the data, about the location, about their usage, about themselves, those are really key, and they need to be aware of what they're sharing, and you need to be transparent what you're doing with that data. Thank you, everybody. We did run out of time because we started a bit late. If you want to contact me, I'm happy to. My email is here. I'm also on LinkedIn, and I wish you all a very nice day at the conference. Thank you, SSVAR, for organizing that, and thanks for having me. Have a nice day. Bye.